Hello, this is Mr. Stansbury. I'm going to take you to the 14L notes on independent events revisited. Okay. At the end of this, you should be able to say I can show that some compound events are independent. All right, so if events, you're going to need to hang with me on this one here. It's kind of a little trick we're going to go on here. But if events A and B are independent, then the probability of A given that B happens is simply just the probability of A. Okay? And then the probability of B given that A happens is just the probability of B. Independent meaning it doesn't have any effect on the other event. Okay? So again, think of this probability of A happening given that B happens. Doesn't matter if B happened or not. The probability of A is just going to be the probability of A. Okay? And then same thing with probability of B. Okay? Also, the probability of A given that B happens is, if we have this here, the overlap part here, is going to be the probability of A intersect B over the probability of B. Okay, so again, the probability of A happening on this here is X and Y, but it says given that B happens, so we're really only choosing, from this B over here, right? We're only choosing from this. So now the probability of A happening is just going to be this Y here. So really this is just simply the probability of Y over the probability of both of these happening, Y and Z. Yeah, I don't know if that's terribly helpful or not, but this here should end up being helpful here in a little bit. Okay. What we're going to do here is we're going to take this here and we're just going to change it a little bit. So I brought this same stuff down here. So it's the exact same thing as all down here in pink. And then I'm just going to multiply both sides by probability of B. So the probability of B here cancels out, reduces down to 1. And then we have probability over here of B. So probability of B times the probability of A given B is the probability of A intersect B. Okay. And again, remember we're on a little journey here, so we're going to get to a place here that is going to give us some important information. Okay. Another way to look at this is just rewriting this probability of A intersect B is the same thing as the probability of A given B and times the probability of B. Okay. Now, what I'm really trying to get at here is that when we know here that this probability of A given B is the same thing as the probability of A. So I'm just going to replace this probability of A given B with the probability of A. That's this right here. Okay, and there's a probability of B, and then probability of A intersect B. So this is what we really are trying to get at, is this piece right here. Okay, so if A and B are independent events, then the probability of A intersect B is simply just going to be the probability of A times the probability of B. Okay, so again, this is important for independent events. Why, you ask? I'm so glad you asked. All right, so let's use this here. Probability of A is 1/2, probability of B is 1/3, and probability of A union B we're going to call X. Okay, so we're going to find X if A and B are mutually exclusive. Okay, so if probability of A and B being mutually exclusive is, if you look at that here, if they're mutually exclusive, they can't both happen at the same time, right? So there's A and there's B. Okay, mutually exclusive means they can't happen at the same time. So that's what that looks like. Okay, so we want to find X, which is the probability of A union B. Probability of A union B is just the probability of A. That's what we went over with our last section here, plus the probability of B minus the probability of A intersect B. Okay, so probability of A is 1/2. So the probability of A union B is going to be probability of A, which is 1/2, plus the probability of B, which is 1/3, minus the probability of A intersect B. But guess what? A intersect B, there is no A intersect B, so that is simply 0. Okay, so we just get 1/2 plus 1/3. Okay, and again, you can do it on your calculator. You can do it on, you know, you can probably do this in our heads too, but let's just do this. 1 divided by 2 plus 1 divided by 3 should give us 5/6. So it's 0.833. So let's do math, enter, change it into a fraction, and that's 5/6. Okay, so that's the probability of A union B if A and B are mutually exclusive. Okay, now over here, probability of if A and B are independent. So what we want to do there is we want to remember that if A and B are independent events, then remember A intersect B is probability of A times the probability of B. So that should hopefully make this a lot nicer. Let's try pink for this problem. All right. So probability of A union B for independent events, well, for any event, is always probability of A plus the probability of B minus the probability of A intersect B. Okay? So probability of A, oops, wrong way, union B, remember that's A or B, is the probability of A, which is our 1/2, plus the probability of B, which is our 1/3. And now we have to minus the probability of A intersect B, which again, from that last screen, remember we got probability of A intersect B for independent events is probability of A times the probability of B. So that's going to be minus, let's see, 1/2 times 1/3. All right? All right, so let's try that out. So we've got 1 divided by 2 plus 1 divided by 3 minus, let's do parentheses just to make sure, 1 divided by 2 times 1 divided by 3. All right, and we get 0.6667, which is 2/3. So that equals 2/3. All right, and that is the probability of A union B. Okay. All right, let's take a quick little commercial break, shall we? Let's shout more Brian Regan because I think this guy's funny.
I got a buddy who thinks he speaks Italian. It's very strange, very strange. He's Italian-American, never been to Italy, never. All my friend can say in Italian are pasta dish names. Oops. He doesn't even know any verbs, but he still tries to pull it off. Oh, my mom, she makes a great manicotti. Sorry, what? My mom, she makes manicotti. She makes it al dente with a ricotta cheese. Are you okay? You sound like you're really weird. I have an Irish heritage. I don't do that. Oh, my mom, she makes a great corned beef and cabbage. It's magically delicious. Then I river dance my way home, you know.
Sorry, that guy kills me too much. All right. Okay, let's take a look at one last thing. Okay. Another way to look at this really is probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. Okay, so we know that's true for all these things here. So mutually exclusive events, here's A and here's B. And so again, A intersect B is going to be nothing because it doesn't intersect at all. Independent events are going to, there could be some crossover here, and that's this little middle section here. So that little middle section here is multiplying the probability of A times the probability of B is what will happen in this little middle section here. Okay? All right, last thing, we're going to take a look at one last example similar to the one we just did, and then away we go. All right, so probability of A is 2/5, probability of B is 1/3, probability of A union B is 1/2. Fine, probability of A intersect B. So we know that, oh, I don't like pink. Let's go back to blue. Probability of A union B is probability of A plus the probability of B minus the probability of A intersect B, right? That holds true for all of these. So we know that probability A union B is 1/2. And then we know probability of A is 2/5. Probability of B is 1/3. And then we're going to find the probability of A intersect B minus, let's just go probability of A intersect B. All right, so we have 1/2 equals 2/5 plus 1/3. So 2 divided by 5 plus 1 divided by 3. Oh, wait a minute, that's not going to work out right. So 2 divided by 5 plus 1 divided by 3 is 0.7333. Let's do that as a fraction. Okay, that gives us 11/15. So we have 11/15 minus the probability of A intersect B. So let's subtract 11/15 from both sides. And we'll get the opposite of the probability of A intersect B, not opposite, but the negative answer of. So let's do this. Let's do 1 divided by 2 equals, and then minus, let's do parentheses, 11 divided by 15. And we get negative 0.233, and then let's do math, enter, gives us negative 7/30. So that means then the probability of A intersect B should just be 7/30 if we get rid of the negatives from both sides. All right. Last one here, probability of A given B. All right, let's take a look at that. Okay, so this is going to simply be the probability of A and B happening all over the probability of B happening. Okay, so let's see, we just figured out what probability of A and B is, so this is going to equal 7/30 divided by the probability of B happening, which we figured out was 1/3. So it's just going to be 7/30 divided by 1/3. 7 divided by 30. And then let's divide that by parentheses 1 divided by 3. And that gives us 0.7. 7/10 or 0.7. So the probability of A given B should be 7/10. All right, so now you should be able to say that I can show that some compound events are independent and how to calculate those. All right, if you have any questions, please ask. Thanks.